The launch of the Hubble Space Telescope over 34 years ago has far exceeded its original mission goals and become one of the most valuable observatories in human history, though it was not initially designed to observe targets within our solar system. Hubble has consistently demonstrated its adaptability by capturing rare and compelling moments that would not have been noticed otherwise. Not every planet or celestial body has a dedicated task, and there is a lot more to the entire solar system, not just the planets. Throughout its journey, Hubble has offered us remarkable insights into our neighborhood in the cosmos, from Earth to the outer reaches of the solar system, revealing a hidden world of activity and wonder. We begin our investigation near home with the natural satellite of Earth. Interestingly, because of the moon's large apparent size in the sky, Hubble cannot capture the entire lunar surface in one frame. Moreover, missions like NASA's Lunar Reconnaissance Orbiter provide images with a higher resolution tailored specifically for lunar studies. As a result, Hubble's precious time is usually spent observing more distant or less accessible targets. However, one exception occurred when Hubble landed in 2012, was utilized during a one-of-a-kind astronomical event, Venus passing in front of the Sun. Scientists study this rare alignment, used the moon as a surface that reflected light to examine the sunlight that had entered. Despite this, Venus' atmosphere uses this method, not intended for Venus itself, whose atmospheric composition is well known, served as a test for detecting chemical signatures in atmospheres. By observing scattered light, it helped confirm the accuracy of methods used frequently by Hubble uses to study the atmospheres of exoplanets when they transit their host stars. Since the Sun is too bright for Hubble to observe directly, using the moon as a giant mirror allowed researchers to extract detailed data while testing a methodology that would become critical in our search for exoplanets habitable. While capturing full views of the moon may not be within Hubble's range, Mars presents a target that is more suitable for the telescope's high-resolution instruments. Unlike orbiters that often provide, Hubble's angled or localized imagery offers sweeping full-disk views of the red planet. These images are critical for tracking seasonal changes, dust storms, and other atmospheric phenomena that influence both our scientific comprehending and planning of surface missions. In one stunning Hubble's time-lapse sequence revealed a global dust storm engulfing Mars, obscuring much of its surface behind. This dramatic event, the two Martian Phobos and Deimos are visible, orbiting in the background. Their movements are especially vivid in a 42-minute sequence in which Phobos' motion stands out due to its close proximity and short orbital period. Phobos, which are larger and are closer to Mars, a full orbit of 2 moons can be completed in just 7.5 hours, which makes it the only moon in solar system that orbits faster than its planet's day. This remarkable celestial dance captured by Hubble not only demonstrates Mars' dynamic nature, but also underscores the telescope's versatility in observing transient and phenomena that are expanding beyond the terrestrial planets. We arrive at the Asteroid Belt, a chaotic region filled with a diverse population of small rocky bodies. Here, Hubble's observations have uncovered some of the most unusual objects in the solar system. One such, the asteroid 6478 G8, was found. Deceptively ordinary-looking body that displays traits more commonly associated. Hubble spotted comets in 2019 and captured detailed images of G, revealing twin tails extending from its body. Although it resides firmly within the asteroid belt, this object behaves in a way that puzzled astronomers. Upon closer investigation, scientists determined that Galt's unusual appearance is due to a process known as the Yarovsky-O'Keefe Redzivsky Paddock YURP effect. This phenomenon occurs when solar radiation causes asteroids of varying sizes and shapes to slowly spin faster over time. G, roughly 3.5 kilometers in diameter, has now reached a frequency of rotation of once every 2 hours, the threshold beyond which its own gravity can no longer hold it together. The rapid spin causes loose surface material to be flung off into space, forming the distinctive tails over time. Gould may completely disintegrate, reinforcing the idea that many asteroids aren't solid pillars, rather fragile rubble piles loosely bound by gravity. These findings aid researchers comprehend the development of tiny bodies in the solar system and the delicate balance that maintains their structural integrity. Another fascinating object within the asteroid belt is P/2010A2, which initially appeared to be a comet because of its long tail and diffuse appearance. However, more detailed examination of its core revealed something entirely unexpected. Rather than being a typical icy body undergoing sublimation, it turned out to be the location of a recent collision between two at high speed. This kind of thing happens to asteroids, exceedingly rare in our solar system, where most large bodies have long, in contrast to the settled into stable orbits. Asteroids are planets and moons of major planets in a turbulent, dynamic environment where collisions still occasionally occur. The aftermath of this particular impact was preserved in the images produced by Hubble, a remarkable structure in the shape of an X nearby the object's nucleus. This unusual feature consists of rocky debris scattered in multiple directions, implying that the accident was likely violent and chaotic event at speeds of tens of thousands of kilometers per second. At such velocities, even a relatively small impact can release sufficient energy to pulverize rock and send fragments soaring through space. Instead of dispersing evenly, the debris followed complex, gravitational, and momentum-driven paths, some of which came together in the end into the striking X formation. This structure provides a valuable and rare opportunity to study the physics of real-time collisions with asteroid bodies, contributing to our understanding of how these events influence the makeup and future of the solar system. In some cases, the gravitational pull of nearby planets can significantly alter these outcomes. Asteroids, if one such object strays too far from the orbits, which are relatively stable within the belt, it risks encountering the enormous gravitational pull of Jupiter. Is frequently referred to as the Sunday, the massive system's vacuum cleaner. Jupiter, more than 2/3 of all non-solar material in the system that enables deflect or capture smaller objects that could otherwise be dangerous for the inner planets. Are a vivid example of this occurred in 1994 when a comet, Levy 9 Shoemaker, veered too close to Jupiter. The planet's gravity tore the comet split in half, forming multiple fragments well before they reached its atmosphere. These fragments eventually slammed into Jupiter in a series of first spectacular collisions. Impact of extraterrestrials ever observed in real time. Remarkably, Shoemaker Levy 9 had been taken over by Jupiter's weight nearly 20 years earlier, orbiting the giant planet until tidal forces brought it too close in July 1990 for the shattered fragments made their way into Jupiter's upper atmosphere at an astonishing 60 miles per hour km/s over 210,000 kmh. The resulting impacts created fireballs that soared 3,000 kilometers above the cloud tops, reaching temperatures exceeding 23,000 degrees Celsius. One particularly significant impact caused a gloomy scar that is visible despite having modest ground-based telescopes. The explosion produced the energy of 6 million megatons of TNT, more than 600 times the power of the combined Earth's nuclear arsenal. Includes these unprecedented observations offered a vivid demonstration of Jupiter's role as a planetary shield, absorbing or deflecting potential threats before they reach another part of the inner solar system. Impacts on Jupiter, albeit less significant, have since been recorded, further solidifying the theory that Jupiter aids in the protection of Earth and its neighbors' planets from catastrophic collisions. Hubble's ability to document such events has transformed our understanding of the solar system as a living, dynamic place, instead of a sterile background from its vantage point high above Earth's atmosphere. Hubble continues to provide unparalleled vantage points over celestial bodies that were previously the subject of speculation or imaging with a low resolution. Whether it's keeping track of dust storms on Mars' asteroid collisions or capturing the fiery demise of a comet under Jupiter's. Hubble's massive gravitational grip reveals the solar system as a place of constant change governed by the subtle forces of physics and time. These observations are not only visually stunning but also scientifically crucial, providing insight into how planets and their moons and interaction and evolution of smaller bodies sometimes collide in a cosmic dance that continues to shape our neighborhood in space as Hubble enters the twilight. Despite the years of its mission, its legacy through a treasure trove of data that will inform generations of astronomers and help pave the way for future explorations by next generation solar telescopes and spacecraft system was once thought to be relatively quiet. An environment that is predictable has emerged through the lens of Hubble, a chaotic, beautiful, and ever-changing realm of motion and mystery. The significance of Hubble's contributions to our knowledge of the solar system cannot be overstated. As we get closer to the outer areas, past the asteroid belt, we encounter the realm of the gas giants, beginning with Jupiter, whose immense gravitational dominance shapes not just its own system of moons, but also the orbital dynamics. Hubble is one of many asteroids and comets, has done extensive research on Jupiter, providing breathtaking views of its turbulent atmosphere, the swirling storms, and rapidly shifting cloud belts visible in ultraviolet, visible, and near-infrared light reveal a planet in perpetual motion. Hubble's high-resolution time-lapse imaging has tracked the Great Red Spot's evolution, anticyclonic storm larger than Earth that has raged for centuries. These scientists can measure with observations wind speeds, track storm movement, and detect minute changes in the air chemistry. Occasionally, new storms appear, either brown barges or white ovals, each which offers insight into the mechanisms that drive Jupiter's dynamic weather. Lightning storms, auroras, and systems, even transient impacts from small asteroids have been captured, further emphasizing the complex interplay between Jupiter's magnetic field, internal heat, and outer environment. Jupiter's influence extends well beyond its own orbit. Hubble has observed interactions between Jupiter and its Io, Europa, Ganymede, and the four largest moons, and Callisto, providing invaluable data about their surfaces and environments. Io, the most volcanically active body in the solar system, spews plumes of sulfur and molten rock from hundreds of volcanoes. Hubble has monitored these eruptions, allowing scientists to study how Io's volcanic activity is fueled by tidal heating, gravitational squeezing from both Jupiter and neighboring moons. Meanwhile, Europa's icy surface, guarded by a complex web of holes and ridges, hints at a subsurface ocean. The ultraviolet spectroscopy of Hubble has detected possible plumes of water vapor emerging from the surface, implying that material from the ocean below may be reaching space. These tantalizing findings have fueled interest in future missions like NASA's Europa Clipper, which will investigate the moon's habitability. Ganymede, the largest moon in the solar system, has also revealed evidence of possibly having a magnetic field, a buried ocean. Hubble's observations of auroral emissions around Ganymede helped verify this by providing indirect evidence of a conductive salty ocean beneath the ice. Callisto, less active than its siblings, has also been imaged by Hubble, showing a heavily cratered surface that speaks to a long and unchanging history. Together, these Galilean moons form a miniature planetary system, each with a distinct story, but all bound by Jupiter's enormous gravity. Extends beyond Jupiter lies Saturn, a planet that has enchanted astronomers. Have used it for centuries. Stunning ring system. Hubble has provided some of the most detailed images of Saturn from Earth's orbit, including seasonal changes in its atmosphere and alterations in its rings, composed primarily of ice particles, range from minuscule grains to Hubble's objects the size of mountains. Observations have revealed minute shifts in the brightness and color of the rings, possibly caused by interactions with small molecules or charged particles. Seasonal changes also influence the revealed atmosphere of Saturn by shifting band structures and the occasional appearance of large storms, such as the massive storm in 2010 that stretched across the entire planet. Hubble has also examined Saturn's moons, including Titan, the second largest moon in the solar system and the only one. While Titan's atmosphere is thick, dense atmosphere makes it difficult to. Hubble's direct observation of invisible light has detected haze layers and methane. Related phenomena, computing results from the Cassini mission Enceladus, another of Saturn's moons, has received a lot of attention because of plumes of water ice erupting from it. The capability of South Pole Hubble to detect the composition of these plumes from afar has contributed to the expanding body of evidence that a subsurface ocean may harbor conditions suitable for life. Continuing outward, we come to Uranus and the so-called ice giants of Neptune. These far-off worlds in the solar system receive far less sunlight and are thus more difficult to observe in depth, yet Hubble has managed to pierce their remote atmospheres and capture astonishing phenomena. Uranus, which has an upside-down orbit around the Sun and extreme axial tilt, has its own set of seasonal patterns. Hubble has monitored the formation of bright bands of clouds and polar storms as the planet goes through its lengthy seasons, although Uranus appears pale and Hubble is featureless and amateur. The so-called ice giants of Neptune, these far-off worlds in the solar system, receive far less sunlight and are thus more difficult to observe in depth, yet Hubble has managed to pierce their remote atmospheres and capture astonishing phenomena. Uranus, which has an upside-down orbit around the Sun and extreme axial tilt, has its own set of seasonal patterns. Hubble has monitored the formation of bright bands of clouds and polar storms as the planet goes through its lengthy seasons, although Uranus appears pale and Hubble is featureless and amateur telescopes uncovered a significantly more dynamic atmosphere with dark spots and storms, varying levels of brightness throughout it, similar to the deep blue of Neptune's surface color, and swift winds make it a fascinating subject. Hubble has captured massive storm systems on Neptune, including the appearance and subsequent disappearance of great dark spot storm formations comparable to Jupiter's great red spot. These characteristics appear to form and dissipate within a few years of stark contrast to Jupiter's long-standing storm. Hubble's capacity for surveillance Neptune over decades has provided a continuous record of these evolving weather systems, crucial for comprehending the dynamics of the atmosphere in environments that are far away and extremely cold. Among Neptune's moons, Triton stands out as one of the most intriguing. It orbits in the opposite direction of Neptune's rotation, suggesting it may be a captured Kuiper Belt object. Hubble has observed the fragile atmosphere of Triton is composed primarily of nitrogen and exhibits seasonal variations. Its surface shows signs of cryovolcanism, ice volcanoes that erupt not molten rock, but water and ammonia. These observations hint at possible activity beneath the surface and even internal heat sources, which are unexpected for such a distant cold world. As we leave the realm of the planets behind, we approach the Kuiper Belt, a vast, icy frontier that stretches beyond Neptune and contains numerous small planets, and their remnants are dwarfed by bodies. The early solar system. Hubble has played a key role in exploring this distant region, identifying and characterizing many KBOs from the Kuiper Belt. It was instrumental in the discovery of moons around Pluto, including Nix Hydra, Cararos and Styxes, which orbit alongside Charon's closest and largest Pluto satellite. These discoveries changed the way we comprehension of Pluto's system and paved the way for the New Horizons mission, which provided close-up views of this complex and surprisingly active dwarf planet. Prior to the arrival of New Horizons, Hubble provided our best images of Pluto revealing surface variations and hinting at the geological complexity that would eventually astonish scientists beyond Pluto. Other dwarf planets have been observed by Hubble, like Ares, Haumea, and make uncovering information about their compositions, rotational speeds, and potential moons. These icy worlds are relics of the solar system's formation, and their study offers clues about the processes that shape the planets and moons we see today. Hubble also contributed to the identification of Arakoth, formerly known as MU-69A, contact binary object visited by New Horizons after its Pluto flyby. Arakoth's flattened, peanut-like shape and undisturbed surface suggest a gentle merger between two ancient bodies, providing a window into the earliest stages of planetary formation. Observing such distant and faint objects requires the sharpness of its resolution and the capacity to perform long-duration exposures free from atmospheric interference. Even farther out, Hubble has contributed to the search for objects at the edge of the solar system and beyond, including detecting on comets and other distant icy bodies hyperbolic trajectories. Its observations have improved orbital calculations, informed mission planning for robotic spacecraft, and enabled the study of objects previously too faint to detect. In many ways, Hubble has served as a pathfinder for more than just science discovery, but for humanity's desire to delve deeper, reach further, and comprehend more about the vast expanse we inhabit. Considering its decades of service, it is evident that Hubble has done more than photographed our solar system. It has redefined our perspective of it, from massive gas giants and volcanic moons to shattered asteroids and ancient icy relics. Hubble has revealed a solar system that is moving and changing in history. Every image it sends back is a reminder that we are part of an intricate, interconnected cosmic system filled with beauty, mystery, and the ongoing potential for discovery. Its work continues to inspire and inform, setting the stage for future missions like the James Webb Space Telescope to delve even deeper into the story of our solar system and our place within